Assalamualaikum warahmatullahi wabarakatuh. So today our group will be discuss about question 3. So I will discuss about question A. So the question is state 3 equation for element I1, I2, I3 by applying Kirchhoff first and second law to loop A1, B1, B2, A2 and A1, B1, C1, C, C2, B2, A2. So the first step is we need to know what's meant by Kirchhoff first law and Kirchhoff second law. So Kirchhoff first law means that the total current going through in a node is equal to the total current going through out of the node. So when we see at the B1, the current going through is equal to I1 and the current going out is I2 plus I3. So we found the first equation is I1 equal to I2 plus I3. Okay, so we move to the next, which is Kirchhoff second law. So what is Kirchhoff second law? Kirchhoff second law is total voltage in a closed loop is equal to the zero. So we're going to have two loop, which is A1, B1, B2, A2, A1. And the second one is A1, B1, C1, C2, B2, A2, A1. So the first one is we're going to create the equation for A1, B1, B2, A2, A1, the inner loop. So the equation going to be E2, ET equal to, and when we see the current, it's going through to the top side first. So it's through the inductor. So the equation going to be equal to L di1 over dt. And move to the I2 in the loop and plus R1 I2. So the equation going to be ET equal to L di1 over dt plus R1 I2. So we differentiate the equation and it's going to be dt equal to L d squared I1 over dt plus R1 di2 over dt. So it's going to be the second equation for this question. And the last equation we're going to find is the outer loop, which is A1, B1, C1, C2, B2, A2, A1. So when we see the outer loop, it has inductor, resistor, and also capacitor. So the equation going to be ET equal to L di1 over dt. di1 because it going through the I1 plus R2 I3. I3 because the resistor at the I3 and plus 1 over C integrate I3 dt. So it's the formula for capacitor. So if we have the equation for ET, so we gonna differentiate the equation. So it's gonna be dt equal to L d squared I1 over dt plus R2 di3 over dt plus 1 over C I3 d. So here is the last equation for this question. So that's the three equation we have found in this question. Alright, we move to the question B.
So I'm going to present for part B question in this. So it's about using the equations obtained in part A, obtain a system of differential equations that describes the current I2t and I3t. So as IZAAZ has stated, he got three equations for the part A. So we're going to use the first equation to eliminate the I1 in equation 2 and equation 3. So we're going to calculate for the equation 2 first. So as this is the normal, this is the original equation 2. So after we substitute the value of equation 1, we got L we got delta t equals to L delta squared over dt, and I multiply with I2 plus I3, then plus with R1 di2 over dt. And then we're going to get a new equation, which is the fourth equation. Delta t equals to L d2i2 over dt plus L d2i3 over dt plus R1 di2 over dt. So we're going to calculate for the third equation. So after we substitute the value of the first equation in it, we're going to get delta t equals to L the d2 over dt multiplied with I2 plus I3 plus R2 di3 over dt plus 1 over c I3 multiplied with t. Then we're going to get the new equation, which is the fifth equation. It's about delta t equals to L d2i2 over dt plus L d2i3 over dt plus R2 di3 over dt plus 1 over c I3t. That's all for the part B question. So we're going to proceed with the part C.
So the part C question, it's given the value of R1, which is 10 ohm, R2 5 ohm, inductor 1, and capacitor 0.2 farad. So for the value of t in between 0 to 2, the value of Vt is 120. So we're going to insert the value of Vt into the both of the equation previously, which is the equation 4 and 5. And don't forget to also put the value of L and R inside the equation. So we will get this kind of equation, the sixth equation and the seventh equation. So this is the Laplace transform of equation 6. So for d square I over dt, when we Laplace the d square I over dt, we will get s square I to s minus s I2 to the value of 0 and di2 over dt to the value of 0. And for the Laplace transform of equation 6, we will get like this one, for, the 8th equation. And for Laplace transform of equations 2, we will get the 9th equation, which is this one. And to get the value of I2s and I3s, we will use the matrix form. I mean the matrix method, which so then I will get like this: I2s equals to 8 5s plus 5 over s multiplied by s plus 2 and multiplied by s plus 5 over 3. And now I will use a partial fraction. So why I'm using the partial fraction is to break a complex rational function into a sum of simpler fractions. So as you can see it here, the I2s, I break it into 3 parts, which is A, B, and C. So the I2s will be A over S plus B over S plus 2 plus C over S plus 5 over 3. And then I will use the cover up method because it's much simpler than using the basic one. So I will get the value of A equals to 12, B equals to negative 60, and C equals to 48. So now I will arrange it, and then I will use the inverse Laplace to get this equation.
Then for I3s, which is equals to 80s over s, s plus 2, and s plus 5 over 3. After that, you should separate them in partial fractions and solve them. You will get A equals to 0, B equals to 240, and C equals to minus 240. And then, substitute back these values into the I3s partial fractions, and you will get I3s equals to 240 over s plus 5 over 3, and minus 240 over s plus 2. Then inverse Laplace equation I3s to get I3t, which is equals to 240 exponential negative 5t over 3, minus 240 exponential negative 2t, multiply with ut in ampere.
40 more than equal to, we need to find I3, I2t and I3t, because we need to substitute into V naught. V naught equals to 10 I2 minus 5. So we get V naught equals to 105.28. We convert into V naught S. Substitute, we get 0 equals to S by 16.779 plus 5 I3S plus 6 over 5 I3S plus 105.58. 28 over 5. We pindah-pindahkan, dapat 16.779 equals to S plus 10 I2S plus S I3S. Lagi satu tu pindah-pindahkan dapat yang equation lagi satu. Lepas tu kita guna matrix form untuk cari I1S dengan I2S. Dah dapat I2S. Yang bawah tu kita boleh factorizekan. Lepas tu kita buat partial fraction. Cari A, cari B. Masukkan balik. Dapat I2S tu, jadikan I2B. Untuk yang I3S, dah dapat I3S, kita pendekkan dia, ringkaskan dia. Lepas tu partial fraction lagi, masukkan balik A dengan B, dapat I3T. Tu je. Next.
Lastly, for part D, we are asked to find the current I1. Now we have to consider that we have two conditions, but basically I1 equals to I2 plus I3. For the first condition, which is t greater than or equal to 0 and less than 2, we have to take the values of I2 and I3 from the same condition. As we saw earlier, you can find the I2 and I3 values in this particular condition in part C. Now, adding up I2 and I3, you're going to get I1 equals to 12 minus 300 exponential of negative 2 plus 288 exponential of negative 5t over 3 multiplied by the unit step function in amperes. Then we move on to the next condition. It's basically the same thing. You take the values of I2 and I3 for the condition t is greater than or equal to 2 that you already obtained in part C. And then after adding them up together, you'll finally get I1 equals to negative 277.671 exponential of negative 5t over 3 plus 294.441 exponential of negative 2t multiplied by the unit step function in amperes. That's all from us. Thank you.